Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Nura'in Nabilah Noranuar from Department of Mathematics. So today I will present my poster on free convection flow of carbon nanotube due to the non-coaxial rotation. So as the introduction, the main purpose of my study is to investigate the fluid behavior by suspending the carbon nanotube particle into the water-based fluid. So by the fact, water-based fluid is found to have a limited capability in transferring heat and due to its low thermal conductivity. So here, the carbon nanotube particle, which acts as the thermal conductivity booster and also have high energy efficiency, are added into this water-based fluid in order to increase more thermal conductivity and a good heat transfer fluid with high thermal conductivity can be formed. Since there is no implementation of non-coaxial rotation is found in the previous publication, so the present study will be conducted by considering the non-coaxial rotation. And basically, this problem involves a very long process to find a solution. And here, the Laplace Transform method can be the best method to use, as this transform will provide a systematic alternative approach for solving differential equations, where the mathematical transformation will be used in order to simplify the solution of this problem. And this problem will be represented in the dimensional form of momentum and energy equation together with the inertial and boundary condition as stated in A. And then the non-dimensional variables are introduced as stated in B. And these variables are used in order to convert the dimensional form of governing equation into the non-dimensional form of governing equation as stated in C. And then this non-dimensional governing equation are solved by using Laplace Transform method in order to obtain the velocity and temperature profile as stated in D. As the result of my study, so we can see from figure 2 and figure 3 on how the nanoparticles are actually influence the velocity profile. The red line here represents the fluid behavior without the influence of the nanoparticles, and from this figure, we can see that the addition of the nanoparticles, single wall carbon nanotube and multiple wall carbon nanotube, actually can cause the both primary velocity and secondary velocity to increase. And same goes to the temperature profile. The addition of the nanoparticle can actually cause the temperature to increase. And from table 2 also, we can see that the increasing of the nanoparticle volume fraction can cause the Nusselt number to increase. And this shows that the rate of heat transfer is reduced by increasing of the addition of the nanoparticle in the water-based fluid. And this such behavior indicates that the implementation of non-coaxial rotation are actually give a directly impact to the temperature profile, which can cause the rate of heat transfer to reduce. And lastly, the validity of the obtained result can be found in the figure 1, where the present result of single wall carbon nanotube and multiple wall carbon nanotube are found to be in a good agreement with the published result by Muhammad by letting the parameter of magnetic field and the nanoparticle volume fraction is equal to 0 and the porosity is approach infinity in the present result. And last but not least, this study has contributed some significance. First, the exact solution obtained in this study is actually can be a benchmark to other numerical or experimental studies, and this will eventually can reduce the cost of the experiment that will be conducted, as the simulation of the fluid behavior can be formed by having this method. And next, this study also can be a good reference to researchers and education, as the Laplace Transform method is actually has been learned in mathematics, and now we can see on how the Laplace Transform method can be applied in order to solve the engineering problem. So that's all for my video presentation. So thank you.